Let's say that f of x is given as x squared, f of x is given as x cubed. Let's do one more. 2x to the fourth. Okay, now it's very easy to find derivatives. There's a little technique you can use, and the technique usually looks like this: nx n minus 1. What this means is you're going to take your exponent, you're going to multiply it forward, and then subtract 1. Okay, so let's do it. So in theory, this is how it would look. 2x, so d over dx. It's going to be 1 multiplied to x 2 minus 1. Remember, in front of x is a 1, so just multiply forward and subtract 1. So if we do that, we get 2x. It's my derivative of x squared. What about x cubed? Well, we're going to do the same thing. Multiply forward, subtract 1. What about this one? Now, let's say we want to calculate the derivative, or we want to find the derivative of 2x to the fourth. It's going to look something like this. 4 times 2, you bring the power forward, multiply it, subtract 1. I got that from 4 minus 1. So then to find the derivative, in this case, is going to be x8 to the third. So let's do a longer example. Let's do something where it's given as the f of x is equal to 2x4 plus 3x squared plus 4. Okay, so one thing to note down in this case, the derivative of any constant is equal to 0. So a constant would just be a value without an x, right? So if we look at these values, which one has no x? It's the 4. So the derivative of 4 will be 0. So let's go find d over dx. 2x cubed quadric plus 2x squared plus 4. I can say, well, the derivative of this is multiply forward, subtract 1. That gives me 8x3 plus 6x, and that is my derivative of the function given. So we can write this two ways. We can write this d over dx, or we can say, well, the f of x is equal to my function plus 3x squared plus 4, and then we can say, well, f prime of x, or the first order derivative, is going to be 8x3 plus 6x. So this prime indicates that the function has been derived. Okay, let's move over to some more complicated examples. What about the f of x is equal to 1 over x? How do we find the derivative? So the first thing you need to know here is an exponential rule. So when we have 1 over x, we want to rewrite this as x to the negative 1. Okay, this is an exponential rule. So I'll make a little notation, or a little note, rule. And we never want to solve derivatives as denominators. So let's go find it. So d over dx, 1 over x. I'm going to move this x to the front. Now we just follow the exact same principle. Multiply this forward and subtract 1. That's then going to give me negative 1 x. 1 minus 1 is negative 2. And I want to rewrite this in its original form. So to make the negative exponent positive, we just swap it from a numerator to a denominator, and vice versa. I always tell my students, this is like when you send your car to a mechanic, right? You want the car in its original form that you gave it to the mechanic. So the same thing we want to do with derivatives. We sort of want it in the original form that we gave it, right? What about this one? What about when we have, well, f of x is equal to the square root of x. Well, here's another rule that you need to know when working with exponents. I would advise that you are very familiar with the exponential rules before starting derivatives. It just makes the process a lot easier. So initially there's a 2 and here's a 1, but these are not written, right? So I can rewrite the square root of a, let's say nm. I can rewrite this as a n over m. So I can do the exact same thing here. So I'm going to rewrite this as 1 over 2. Now we can find the derivative, right? So let's now say d over dx, parentheses, square brackets. Let's say the square root of x. That's going to give me 1 over x. I'm going to subtract 1 and multiply forward. So that gives me 1 over 2 x. And then negative 1 is going to be negative 1/2. So what do I do now? Well, I'm going to quickly rewrite this a bit more neater. So 2, 1, x, negative 1/2. I remember earlier when I said we want to take our negative exponents to the bottom to make it positive. I'm going to do the exact same thing. So it's going to be 1 over 2 x 1/2, and then I can rewrite this back in its original form, okay, by saying 1 over 2 square root x.